Now we're dealing with example or exercise 5. We have two very long wires and they carry each a current. Wire 1 carries a current of 8.3 amperes as we see in this figure 29. What should the current in wire 2 be so that the net magnetic field due to those two currents is 0 at point P? So once again I start with the resultant field at point P is 0, and the resultant field at point P is due to B from wire 1 and B from wire 2. The problem is I have to figure out the sense of the magnetic field. Wire 1 carries a current that goes into the page, so according to the right hand rule it creates a magnetic field directed at point P that way. This is B1. Wire 2 should carry a current as such, a dot going out of the page, so that according to the right hand rule it creates a magnetic field directed in that sense, so that they must oppose each other, and the reason is the net field is 0. Okay, this is where it says the net field is 0. So that must mean B1 should be the same as B2 in magnitude. And the magnitude of a wire, of the magnetic field created by a wire carrying a current, is mu0 over 2 pi I1 over D1 should be the same as mu0 over 2 pi I2 over D2. If we just eliminate those, we end up having I1, which is given as 8.3, over D1. D1 is the distance that separates wire 1 and the point in question, point P, which is D1 and D2. So it's 0.75 plus 1.5. Be careful, those are in centimeters. We can leave them. Over I2, which is required. This is what we're after, over D2, which is 1.5 centimeters. And we could have left them in centimeters. And you end up having I2 so many amperes. Okay?